Hey guys, it's Barratt with the Gimpy Camper. About a year ago, I upgraded and moved the majority of my rig's electrical system. I had a few key goals when I did this, and I wanted to be better able to control any parasitic draw that was powered at any given time. You know, this even comes into play more so in the winter time, as occasionally in the winter my batteries do die because my 300 watts of solar just doesn't get enough sun to keep the batteries charged. So now I live in southeast Tennessee and we don't get a lot of snow, but we just have a month or two where we just don't seem to get enough sun to keep the batteries charged. I do generally like to use the camper throughout the winter, so I like everything to be ready to go when the battery's full and not have to worry about charging anything before I leave. Truthfully, right now I have the camper at my dad's house in northern Michigan for a family emergency, where I plan on keeping it all winter long because I'm crazy. You know, we will have a video about our winter adventure here as well. You know, with my lithium batteries, I'm not as concerned because unlike lead acid batteries, they don't have to stay charged above 50%. My line energy batteries actually support draining them down to 0%. In order to get an electrical system that serves us better and goes the extra mile that we need, you know, I attacked this from two different prongs. I added a third line energy battery, which is also something you can do with lithium that you just can't do with lead acid. Any degradation in a single battery actually lowers your whole system with lead acid. You know, this is why when you replace those lead acid batteries, you got to replace them all at once. With lithium batteries, you know, depending on the manufacturer, you can do this a year or two later, and there's such minimal loss of the voltage in the original batteries that it doesn't seem to affect the whole system. On top of adding the third battery, I did move the batteries back out to the front storage area, which is where my factory battery bank was actually located. Another goal I was working on was to create more room in the basement. You know, I have sealed the front compartment around the landing gear, and I used to be against putting any electrical components here for fear that water damage could get in there. The water can, you know, get in during travel day, you know, when it's rainy and stuff. But apparently I'm over that these days. You know, I did seal up around the landing gear with some T-Rex tape, and it seems to be holding just fine. You know, to hold the batteries down, I'd use some tie-down straps, and I just screwed those to some L brackets on the floor. I put the L brackets there to hold the batteries in from side to side and around the front, and then I put the straps over the top, and I just ratchet those down a little bit. But they're actually screwed to the floor underneath the L brackets, how I keep them held down. One thing about being here in Michigan is this winter I'll actually be able to test out these heating pads that I put on those lithium batteries and make sure they're working properly. You know, then I focused after that on moving all of my components out to that front compartment. To be honest, it was like putting a puzzle together. I placed all the large components in first, and then I figured out how to route the cables and the bus bars, and I added the solar charge controller, the inverter, the converter, the 12-volt distribution block, and the shunt for my battery monitor. You know, after I got all that in, then I put bus bars in kind of where I thought that they would line up, but I still had to move things a couple of times. You know, my plan for the bus bars was to use multiple cutoff switches. The theory was that everything on the first bus bar can be left on if I wanted, or we can completely turn off the entire power system to stop any of the parasitic draws. The thought is that in the winter time when the sun isn't providing as much power, I can power the converter, the slides, the electronic dump valves, my 12-volt distribution panels which supply power to my backup lights, my internet router, my TPMS relay, my Blink security system. Leave that on with no issues whatsoever, right? But cut off the power that I don't want there. You know, my solar charge controller is also hooked up to this first bus bar, as this way the solar charge even if I have most of the rest of the camper turned off. So my thought was I would put a cutoff between this first bus bar and a second bus bar, and with that second bus bar I can turn everything off that's not predominantly needed for like travel or anything like that, and which would mainly be like the factory 12-volt stuff from the trailer, as far as, you know, the lights and stuff like that. I don't have to have power going to all that stuff, and the smoke detectors and all that, just for driving down the road. Also had my 2000 watt inverter hooked to that second bus bar, We had a little bit of an issue there, which we'll talk about in just a minute. Now, when making these connections, I did use wire that was too small for the possible amperage coming out of the inverter. I originally had it wired with tube AWG. However, someone pointed out that my 2000 watt inverter at 12 volts does put out more amperage than that wire is really rated for. So I then went back and I changed everything to 2-aught AWG. You know, because I did make this change, I had to get a larger crimper. Of course, I had to get all new ends for my wires and everything. You know, it's a big old expensive mess, and I don't know everything, and I never try to tell you guys I know everything. I'm just telling you how I did it. Now, I did use welding cable for that 2-aught cable because it's more flexible. And, you know, I still had to adjust the exact location of some of the components, especially those bus bars and the cutoffs a few times. It was more complicated making those turns and stuff than you would think. It's like putting a puzzle together. I'll also go over the rest of the components that I have here. You know, I have the 2000 watt Renogy pure sine wave inverter. The inverter does have a remote switch inside the camper so I can turn it on. It is hardwired into a twist lock receptacle. Now, that twist lock receptacle is the same receptacle that's on my onboard Predator 3500 generator. So basically, I have a large extension cord that runs all the way through the underbelly. So basically, I have a large extension cord that is routed through the underbelly. You know, it was originally routed underneath the camper in my original video, and it ran along the hard propane line. But since I had to get under the underbelly to do my sewer hose connections there, I rerouted that wire while I was down there. You know, that extension cord does go to an automatic transfer switch that's mounted right in front of my furnace, right beside my power distribution center. The other power source to the transfer switch, which is the main power, comes straight in from the 50 amp shore power inlet. It goes through my power watchdog and right into the transfer switch, and that's what I have it set on as the default setting. So if you plug into shore power, it automatically goes through there to the power distribution center. Now, if you don't have any power there, or even if you do, if the transfer switch senses power from that other cord, either from the inverter or the generator, it switches power over to that. Now, the way that my power system's set up is that 2000 watt inverter is not strong enough to power all of the things in my system. So when I turn that inverter on, I have to go to the breaker box and I have to flip off all the high draw items such as the air conditioner and the fireplace. You know, the next big part of our electrical system is the WFCO converter that I have. The converter has a 20 amp cord that runs through the underbelly as well, and we just ran that at the same time that we rerouted that other power cable through the underbelly. So we've got two birds with one stone on this one. Now, that wire runs all the way back up to the front to the distribution center. I had installed this converter initially just to use for a rapid charger with the generator, but I was so happy with it, and it charged like twice as fast as my other lithium converter. And so I was in there like running the cable, and I thought I might as well run this other cable and just use this converter all the time because it kicks that other converter's little booty. Now, one reason that I think that the other converter was slow, because the converter was mounted in the power distribution center, which is all the way in the back of the camper, and had some smaller gauge wires that went all the way 29 feet to the front of the camper. And so with the converter being there and sending the AC power out to it over the longer distance and a shorter distance of the DC power on bigger cables, because I was able to fit some 2 AWG cables in that thing charges way faster. Then we'll talk about our solar system. So, you know, our solar system that we have is the Renogy 300 watt premium solar system. You know, it's not big enough for, you know, full-time RV life without any other means of charging the batteries, but we aren't full-time. And we do have a generator built into the camper now. So we have the Renogy 40 amp solar charge controller with our 300 watt system. And in the summertime, those flat mounted solar panels on the roof usually do somewhere between like 9 and 12 amps of power input from the sun. Also, if needed, we do have a power cutoff switch inside the basement for the wires coming into the solar charge controller, but that wire wasn't long enough to move that switch out into the front panel. And, you know, that's not one that we use too often, basically if you're just working on the system there, so I was fine leaving that cutoff switch inside the basement. You know, the item that we use to monitor the beating heart of our power system is our battery monitor. You know, a lot of people don't think that they need one of these, but I'm telling you, it's so much better. It's so much better to have the battery monitor. I think that that's the most underrated appliance that you can have. I'm telling you, it's so much better than just the cheap things that come on the RVs that have like 3 or 4 lights to show a percentage, or even like the ones that show the battery voltage. You know, you can see exactly how many amps are coming in, how many amps are going out. You also have an exact percentage of how much is left in your battery with no guesswork whatsoever. Now the one we have is just one of the cheaper ones off of Amazon. I do like the ones better that have shunts and not any other form of hookup. You know, my cheap one doesn't have any frills, like you can't check it on my phone, but it gives me the information I need, and I didn't have to spend an exorbitant amount of money for it. We do also have our heating pads for our lithium batteries, which those are from Ultra Heat. You know, Ultra Heat is the ones that manufacture the heating pads that Battleborn uses in their heated batteries as well. You know, given that I added the third heating pad, I did have to add in their relay, which does have a temperature monitor with it. I did wire the pads up by using some smaller bus bars because it's quite a few wires. And everything that I wired up on the switch as well, because I don't want to burn power by heating the battery pads up in the dead of winter whenever I'm not using the camper. So, you know, my batteries have a BMS that protects them against charging when it's freezing, which is one of the few things that can hurt a lithium battery. We also did add a soft start to the air conditioner during all this too. You know, when that came in very handy whenever we're using the generator. We were actually mooch docking at a friend's house with a 15 amp outlet. And then the only other remaining parts to our systems, the 2-watt wire, the cutoffs, the bus bars, and the fuses for the inverter and the charge controller. So let's talk about things that these changes did improve. I did not have a dead battery last year all winter long. And you know, that's just from adding the third battery, because I never even turned off both of the cutoffs. You know, I'm also not very good at conserving power when we're dry camping. With the third battery, you know, we use all the power we want. And even when we're using the furnace, most of the time we'll wake up in the morning, we'll have about 60% left in our batteries. During our trip to South Dakota last year, we had a few days that we didn't even have to use the generator at all. And whenever we did use the converter, we just used the generator for an hour or two, charged it up a lot faster, and we didn't have to leave it running all the time. I also really like not having to run power cords outside every time we wanted to use the generator or the inverter or anything like that. And then if we were using the generator and we want to switch back over the inverter, all I had to do was go out and unplug the generator and plug it into the inverter receptacle. And that was really nice. You know, my initial plan was actually use a second automatic transfer switch just for that option, but it wouldn't work with my setup, and it just wasn't strong enough to make the power go from the inverter through 2 different transfer switches. So we set it up to do by hand, and really it works fine for what we need. Now, as always, I'm going to discuss with you guys the things that didn't work so well. Initially, we were having trouble with our auxiliary power cord, you know, the power cord coming from the generator, and the transfer switch dropping low voltage and then cutting off when using the generator to power the air conditioner. So we did have to use an external power cord just the way we did before, from the power inlet to the generator whenever we were using the air conditioner. However, after we added a soft start that resolved that issue, we don't have to run that outside cord anymore. You know, the next thing that we had a problem with was whenever we used the microwave in the camper, it would also lower the voltage of the transfer switch whenever we were trying to power it with the inverter. This was first noticed when we were in South Dakota as well. I asked for some help in some Facebook groups, and a lot of people said it could be from all the connections with bus bars because I had it on that second bus bar, and you went through a lot of connections to the inverter, which is one of the highest draw items that you can have. So I did change it, and I went straight from the positive battery terminal on the battery bank straight to the fuse for the inverter, and then I went straight from the shunt to the negative connection on the inverter, but that didn't help. You know, it did seem to do better if I turned the power setting down on the microwave, but then I thought I fried the microwave because it actually quit working for a while. You know, apparently you're not supposed to run a microwave with nothing in it because that can mess it up. Who knew that? I didn't. The microwave did start working again. My next thought was to change the microwave because I read a lot online that, you know, lower wattage microwaves might work better. So I went down to the Walmart and I picked up the cheapest microwave that I could find, which was bound to have the lowest power draw. And my initial testing seemed to be great. However, it was apparent before too long that that's still an issue. After initially testing, I'd already dumped the RV microwave in the dumpster, so it was a little too late to go back with that plan. You know, I was also looking for a way to trim out that microwave so it would be cost effective, but still allow for some ventilation. Initially, my plan was to have a shelf over the microwave for like sandwich bags and stuff like that. But according to the directions of the microwave, that was going to be too restrictive. I ended up finding this decorative metal screening from Home Depot, painted it black to match, cut an opening for the microwave. You know, it does provide a more finished look. I did go back and add black screws to it to try to help finish it out a little bit, but I'll admit, it still looks a little redneck. You know, I did go back with a laser thermometer when running the microwave for about 5 minutes, and I didn't find any connections that were hot or anything like that on the electrical setup out front, so that made me feel a lot better. But since that transfer switch dropped out initially when using the generator to power the AC, but worked fine when you connected in the traditional cord, you know, I had this idea that maybe it was the transfer switch. I mean, I know that the voltage was dropping a little bit, but it was just for like a second. And so since it worked for the generator and the air conditioner, I thought, well, we'll try it with this. So I spent all day this week, one day, taking out the transfer switch, taking the wiring out of it. And I actually built a 50 amp power inlet, an open box to fit one of those in, and just took the 2 wires and put twist locks on both of them, just like outside the RV, and that way you could manually change it by hand. And I got all that done, and it still didn't work. So since it went back to turning the TV off every time I turned the microwave on, I thought, well, you know, I don't want to deal with that, so I'm not going to get down there and change it by hand if the automatic transfer switch is doing the same job and doing it just as well. So I took an hour this morning and went back in and changed it. So here's where I am. I thought that 2000 watt inverter would be enough for what we wanted because it was supposed to have a 4000 watt surge, which, you know, shouldn't be an issue for a microwave. You know, I think that 4000 watt surge on this Renogy inverter is probably just a pipe dream, actually. And I think that's what the issue is. You know, I don't dry camp enough to spend another few $100 for a larger inverter just for the microwave. You know, we'll just add the microwave breaker to the list of the ones that we flip off whenever we use the inverter power. And we'll just have to use the generator for dry camping when we use the microwave. I mean, the main reason that we wanted to add the inverter was to power our electronics, our TVs and computers and stuff anyway. You know, I did go back, like I say, and install that automatic transfer switch back so that I didn't have to get in there and manually change anything. It still kind of aggravates me that the inverter doesn't work with the microwave because I put a lot of work into that, but it is what it is. And if you have any idea of something that I didn't think of yet, and you just got the answer for me to make it work, hit me up down in the comments, let me know. But here's my true final thoughts. So, you know, it seems very expensive at face value. However, I wish I would have just went with the Victron Multi Plus. I didn't know when I looked at them initially that the warranty's a lot longer than a lot of these cheaper components, for one thing. Also, you know, if you start from the beginning, you know, you're buying an inverter and a converter at the same time. So it's going to kind of even out that cost a little bit if you didn't have one. Now, the one reason that pushed me into buying the inverter separately is because I already had a lithium converter, which I didn't think that I needed to change out, but apparently I did. And truthfully, looking at the forums and stuff, you just don't see people complaining about the Victron stuff because it just works. You know, I don't have any other problems out of any of my Renogy stuff yet, but I know that the customer service isn't the best from what I read. I'm just not going to be able to run the microwave on the inverter, and I am a little ill about it. You know, besides that, I'm really happy with all these changes that we've made. They've helped us in our off-grid trips this year, and especially even like just light docking on the way up here to Michigan and stuff. They help a lot. You know, we'll keep using this stuff to come, and we'll let you know how it's working out. But so far, I've been happy with everything except for that dadgum inverter. But guys, thanks for following our video here. Thanks for looking at all our electrical upgrades we've done. Like I say, this is how we done it. I'm not an electrician. I don't have any certifications or anything. It's just what I did, and I'm just sharing it with you. You know, you're going to do this at your own risk if you do any portion of this stuff. But the one thing that you need to keep in mind is what I didn't really keep in mind that well to start with, and that's the amperage. So what you need to keep in mind is the amperage there. So if you're doing 12-volt system and however many watts you're doing, if it's 2,000, 3,000, then you need to look at a chart there and see how many amps that's rated for, because that's going to be a lot of amps. And people, even people that are like mechanics and stuff, they're like, oh, that 2-gauge wire, that's big enough.
Do not forget to hit that subscribe button.